If there is one emotion that drives humans more than any other, it's curiosity. It doesn't matter how many questions we ask, how many answers we get, or how many things we know, the need for us to understand our world in more and more detail is almost as vital to us as eating or breathing. Science literally means to know. It is a systematic process we use to increase knowledge, or at least to reduce our ignorance of the world that surrounds us. Whether it is figuring out the best time of the year to plant fresh seeds or harvest a crop, or trying to find out which plants can help with a fever or a headache, or just debating with your fellow tribesmen around the fire about the true nature of stars and planets, curiosity has become a fundamental part of being human because it helps our survival. For the longest time, knowledge was built using an often dangerous and easily misleading process of trial and error. We tried something out, we failed, we changed a detail and tried again. Maybe it would work, maybe we would be worse off, but over thousands of years and hundreds of generations, knowledge nurtured in this way could become extremely powerful and detailed. Our ancestors were smart. They could predict eclipses hundreds of years into the future, design structures that could align with the sun and the planets and stars, develop farming practices uniquely suited to local climate and pests, devise sophisticated surgery to repair injury and disfigurement. But the problem with this hit or miss approach was that it did not allow for us to develop a systematic body of knowledge, which meant that it ran into trouble when faced with an unexpected observation or a contradiction. For example, the idea that the Earth was the center of the universe was taken as absolute truth for centuries, and for a person to think so seemed perfectly correct and natural. The entire universe seemed to revolve around the Earth. It was only when men like Tycho Brahe and Johann Kepler began to make systematic observations and analysis over long periods of time that we began to realize the mistakes in our assumptions. Another example of why human intuition can be badly off the mark was the idea that things become visible when light from our eye hits things in our environment. To us, this may be laughable, but many great philosophers and mathematicians believed this to be true for a very long time. A systematic approach where an idea is introduced, tested against observed data, and in turn modified or discarded is known as the scientific method. Physics is that subset of science that deals with processes and principles that govern the physical world. There are two main objectives in physics: unification and reductionism. Unification tries to find underlying relationships between seemingly different phenomena. For example, Ørsted and Faraday discovered that the flow of electrical charges is linked to magnetic phenomena. Later, another scientist named Maxwell gave us a unified view of electricity and magnetism, which is what we call electromagnetism. Reductionism deals with trying to understand what goes on within matter at the microscopic scale and how it decides the behavior of matter on the larger everyday scale. For example, thermodynamics deals with the behavior of bulk matter, while kinetics and statistical mechanics delves into what molecules and atoms do when their thermal energy is changed. So what did this systematic method of observation and theory do for physics? Well, by systematic observation and experimentation, scientists like Galileo and Newton and others realized that, number one, the universe was a lot bigger than anything we had estimated. Number two, we were pretty insignificant on the cosmic scale, and perhaps most importantly, everything that happens around us happens in accordance with a set of laws that can be figured out. Galileo was the first to really take a look at the heavens with a telescope. Yes, telescopes had been around for a while before him, but Galileo was the one who first used it to figure out that we are not the center of the universe, or our galaxy, or even the solar system. Newton, who clearly had a great relationship with his hairstylist, figured out why there is an up and down by introducing the word gravity. Due to the work done by these men and many others like them, physics has allowed us to greatly expand the limits of what we thought possible. Whether it is sending a spacecraft with pinpoint precision to reach a planet after traveling billions of miles, or building a skyscraper a mile high, or a submarine that can keep its Crew, alive and safe in the deepest, darkest oceanic trenches, physics is your friend. But where can physics take us? What are its limits? How do we know the right questions to ask? Let us find out together.
Manorama Horizon. Learning made simple.